Hello, everyone. My name is Michelle, and today we're going to be talking about some basic calculus concepts, tangents and derivatives. So today we're only going to be talking about definitions. So no math, no calculating tangents and derivatives. That will be another video. Now to start off, if this little guy's face right here is your face when you hear tangents and derivatives, then don't worry, because in this video, I'm going to clear up exactly what tangents and derivatives are and how they relate to each other. Once you understand what these calculus concepts are, it'll be a lot easier for you to understand the math. So let's get started. Part 1, tangent lines. Here we have a graph of the function f of x. And right now, it doesn't really matter what f of x is, but just know that here we have a function f of x. Now here is an example of a tangent line. So let's just look at this. We have a point, this orange point, AB, and we have this green tangent line. So you might notice that the tangent line is kind of attached to f of x at this point, AB. We'll see that in the next example too. So here's an example of another tangent line. Our point AB has moved over here to the right side. We still see that the tangent line is kind of touching the function f of x at this point, AB. And with this knowledge, we'll go into the definition of a tangent line. A tangent line is a line that touches a function f of x one time at a point AB. So yeah, that's literally all a tangent line is. It's a line that's kind of touching the function. I'll go back to the graph. And it's touching the function as a very important point, AB. And we'll talk a little bit more about tangent lines in our next section, part 2, derivatives. So there's not really a visual for derivatives, so we'll start with the definition. And we'll actually go through a couple iterations of a definition of a derivative, and the idea of a derivative should slowly start to make sense. So here's kind of the most vaguest, technicalist definition of a derivative I could think of. A derivative is the instantaneous rate of change of y over change of x. So let's kind of dissect this definition. So instantaneous. Well, that means in an instant, at a single point. And well, what single point have we been talking about this entire presentation? Oh, point AB. So let's keep that in mind. A derivative has something to do with a moment at point AB. So on to the next phrase, rate of change in y over change of x. Now you might have heard this phrase before. You might have heard it as rise over run, or you might have heard it as y2 minus y1 over x2 minus x1. And if you see where I'm getting at here, rate of change, all that means is slope. So with that, let's move on to our next definition of a derivative. The slope, change in y over change in x at a point AB. Now, I said in the beginning of this presentation that we were going to connect derivatives and tangent lines. So let's think about it. This is the slope at a point AB. Well, what else do we have at a point AB? We have our tangent line. And well, what does a line have? A slope. So let's get to our final definition of a derivative. It is the slope m equals the change in y over change in x of the tangent line y equals mx plus b at AB. Now that was a lot of variables in one sentence, so let's kind of slowly go through this. The slope, m, which you probably already know from your other math classes, of our tangent line in the form y equals mx plus b, which you might remember as the slope-intercept form of a line, and at this special point, AB. And again, the reason I keep saying at AB is because a derivative is the instantaneous slope or the instantaneous rate of change. So at that point, it's not going to be the overall or the average rate of change or slope of the function. Now we are back at one of our earlier graphs. still we have the point AB with our tangent line y equals mx plus b. So to make sure you understood this presentation, I'm going to ask a few questions. So first, just looking at this tangent line, is the slope of this tangent line positive or negative? Right, so the slope is positive because the line is going up. If we imagine, a person walking on the line, they'd be walking up. So therefore, we can say that the tangent line at point AB has a positive slope. Now here's another question. Is the derivative at point AB positive or negative? Right, the derivative is positive because the slope is positive. And the slope of the tangent line is the same as the derivative at a point AB. So kind of combining all of our definitions and stuff, we can conclude that at point AB, the instantaneous rate of change, which is how the function is acting at that point AB, is positive. All right, that's the end of the presentation. I hope I was able to clear up any confusion you had about tangents and derivatives. I think it's so important just to understand these core concepts because, and I'll be honest, as I'm learning calculus right now, I keep having to go back to these basic concepts as I learn more, because when I get confused about a new piece of information I just think back to, oh, a derivative is the slope of the tangent line. And then suddenly it makes sense, and suddenly I can do a lot more. So although this stuff seems easy, and you might want to skip right to the problem solving, these basic concepts are so important. Again, thank you so much for listening, and I hope you have a great day.